Welcome to Insect Builder channel, large language model automators, Python experts, and my dear friends. Let's deep dive into SelfQueryRetriever with Langchain. Explore the pros and cons of building SelfQueryRetriever, and we are going to use the Google PaLM LLM for this particular activity. Before we dive into the SelfQueryRetriever, we have to understand what is the challenge that is getting solved. In case of a regular retriever, the search results that is provided by the retriever is approximate in nature, because the vector search by default is not accurate. It's not deterministic, meaning the algorithm tries to get the approximate neighbors that is nearest to your query, and then it responds with the documents. This can be sometimes really useful, and sometimes it might give you an answer which is no longer useful for you. Another challenge is that this particular algorithm, the approximate nearest neighbors or k nearest neighbors, the algorithms that is implemented by the vector stores also can be different. Third factor is the embedding functions themselves. The vector search works based on the vectors that is created from the documents. Again, I'm repeating, the vector search or the vector querying works based on the vectors that is created on the documents that you have, on the split documents that you have. This vector creation process is actually done by machine learning models. We have a lot of models that is already available, both closed and open source. I have discussed about the various embedding models available in the using the benchmark called as MTEB. So you can take a look at my earlier videos for that. I'll be attaching that also. These functions also have an impact. And the last two factors are mostly dependent on how you actually do the activity, how you split the documents, what is the size of each of the split that you are going to use in the text document, and what kind of number of documents that you are going to retrieve. All these things have a impact on how the retriever works. So how SelfQueryRetriever mitigates this is what we are going to see today in this particular video. And we are going to also look at implementation of the SelfQueryRetriever in Chroma DB, and the raw data that I'll be using for creating the VectorStore will also be shared with you guys in the GitHub repo. So I'll be showing you where to find those data and the information. I believe that you will like this video, and the follow-up videos that I've been making on Langchain, large language models, and various libraries in the Python ecosystem for the machine learning and artificial intelligence related libraries. Do share this with your friends and colleagues who are looking for getting a heads up in large language models and artificial intelligence domain. Do subscribe to my channel for further updates directly to your YouTube dashboard. With that said, I would like to go to the browser where we can take a look at the actual code. So this particular code, Jupyter Notebook, will be shared with you guys. The link will be shared. This is already committed to the GitHub repo, so I'll be sharing this link. You don't need to worry about it. This is the code that I'll be using. And if you're new to Langchain and you are new to large language models and how the things work, take a look at this particular playlist where I have been covering Langchain along with OpenAI large language models. But now I have shifted to Google PaLM also. So the reason is just to show that how easy it can be to shift from one large language model to another large language model once you understand how the Langchain framework works. So with that, I would like to move to the next step. Before we go into the code, I would also want you guys to take a look at the retrievers that is already available, and from the retrievers option inside the Langchain documentation, you can find the self-querying with Chroma here in this location. And to understand the concept of self-querying, you can take a look at this particular page in the documentation. This documentation is pretty straightforward. I really like the way the Langchain team had provided the information. The point here is that the SelfQueryRetriever uses a query constructing LLM chain. So once you create the self-query retriever, like the process of creating a self-query retriever is provided here. Once you call this primitive, once you initiate this primitive, then internally a query constructing LLM is created, and that LLM queries itself, meaning it queries the vector store and it gives the output. So there are two things that works. So there are, apart from the semantic similarity comparison, to get the contents from the vector store, it also extracts the filters from the user query. So both of these things I'll be showing you how it works. So once you see the data, once you understand how the filters and the query is working, you will understand the impact of the self-querying retriever. And if you observe that here, you see we have to install a Python library called as Lark. And if you're thinking what is Lark, what that library does, then you're curious like me, which will lead you to search for the parser, the Lark Parser, and you will find that the Lark library is a toolkit in Python that can help in parsing any of the languages, programming languages out there, and also to a certain extent natural languages also. So this particular library is used by the self-querying process. Internally they are using these libraries also. We are not, see, this is one of the challenges, at the same time beauty of Langchain. The Langchain team and the developers inside have a wide array of experience, and they are bringing all those experience into one particular framework, Python framework, and they are connecting it with large language models. So understanding each of these parts is very, very important. So give your time and the concentration on learning about the fringe, I shouldn't say fringe libraries, but because they are important also. So you have to understand these libraries to a certain extent, so that when you are using the Langchain primitives like the self-query retriever here, you will know what is going on inside. This is one of the points that I wanted to highlight before we go to the code. So with that said, I would like to close these, and I want to show you the documentation, or I want to show you the raw data that I will be using for creating the vector stores. So basically these are the concepts, the quick start guide, etc. I can download it by clicking on this download button, and I can get the PDF file. I have downloaded these files as PDF, and then I am using that to populate my vector store. So that is why I'm showing you these links also. And with that said, let us go to the code. I have already shared the code in the GitHub repo. That will be there. You can open that code either in your own Jupyter Notebook environment, or you can use the Google Colab environment that you see here. And you see, I start by installing the various libraries that is required. These two libraries are required for the Vertex AI platform, and also ensure that you have created a security account and you have generated the JSON file. So all these things have been explained in other videos in the associated playlists. I will also be attaching the necessary videos along with this discussion also, so you guys can come up to speed rapidly. So here you see this particular runtime. I've been using it for making the particular video and also this particular discussion. I have already uploaded the various PDF files here. You see the files here, and I'm going to parse these PDF files as text, and then I'm going to split the text into smaller chunks, and then I'm going to, sorry about the disturbance. What we are discussing is regarding the PDF that I have already uploaded. This PDFs will be parsed, and then I'll be explaining this code also, and I'll be splitting them, and then I'll be loading them into the Chroma DB. So you'll be seeing all these things in the code right now. This particular function that I have created here starts by taking the PDF path, the file location. It loads using the PyPDF loader, and then what it does is it gets the text. So basically it will get the text inside the page. Each page will be split into separate documents, and then each of these documents have to be again split into smaller chunks, because a page can contain a huge amount of data. And if you are not going to split it into smaller parts, and if you send it to the large language model, then the large language model will throw an error. To avoid that, I mean, the context has been crossed error. To avoid that error, we have to split the pages further. So we can split the pages into 2 or 3 documents. So depending on the chunk size, you can split it. This chunk size that is decided not by any kind of formulation or any kind of proper documentation. This is purely through experimentation, depending on the data that you are having. Currently, the data that I am having, as I showed, is providing a good result using this chunk size. If it is not providing a good result, then you can always change this chunk size and see how is the output. Keep this in mind, because as we discuss this particular self-retriever, you will see that this number matters a lot. And once we have this recursive character text splitter, we can split the documents that we get from each of the document. This is each of the PDF file. We can split it further, and then we are getting the final list of documents. What I'm going to do is I'm going to use the globbing library and glob all this PDF files here, only the PDF files, and then I'm going to create the documents out of it. So this particular list, all docs, will contain the documents. Once I get these documents, there is 150 documents total. I am going to next. So I am going to use Vertex A embeddings, and I'm going to embed it. But before doing that, ensure that your Google application credentials is loaded in this location. Wherever you see this particular JSON file should be here for it to work, or else this particular cell will error out. And once you start by, this is something to avoid any kind of pollution from the multiple runs that you can do in this Jupyter notebook. So that's why I have assigned empty string to VectorDB. And after that, I am going to create a persistent Chroma DB. The reason why I'm using persistent is very simple. Vertex embeddings, the vector embeddings that you get from the embedding models from Google or OpenAI or whomever it is going to be chargeable. In order to save cost and also save the resources, it is always better to store the documents in a folder and zip it and keep it ready. Okay, this is what I have done here. So if you see here, if you go down, I have already collected this as a zip file, and this zip file is also shared with you guys. So it is already available inside the repo. If you want it, you can take it from there. You can easily search it in the GitHub repo that I am sharing. The same link for this particular Jupyter notebook that I'm sharing will have the database zip file also. Once you create this persistent Chroma DB, you have to first of all send the documents. So this is the all documents that you got from this particular activity by loading various PDF files. Here what will happen is, if you are having a large number of documents, say 200, 500 or 600 documents, which is huge in number, then Vertex, the platform, Google platform, will throw an error telling that your rate limit has been crossed. So to work with that rate limit, what you can do is, first of all, send say 100 documents from the list of documents that you have collected. That will create the initial VectorDB instance. Persist that Chroma DB. So this is key step. You have to persist the Chroma DB, and then you have to again instantiate the Chroma instance like this. After instantiating that, then you have to add the documents. If you try to add the documents to this instance, like when you are creating from documents, and if you try to make the add documents to this, it will not work. You must be already aware why it will not work, because the way this particular VectorDB is instantiated is from documents, right? This is already calling a method. If this is not calling the class, that is why it will not work. So ensure that you do this. I made the mistake. That's why I know. I did not read the document. So the way I learn the Python or any of the programming language framework is directly experimenting with it. So if you go back to the PDF, I always insist that you practice. That is something that I do. Always I practice, and the way I practice is to find new challenges and then explore that challenge, how it can be solved using the framework that I'm working on. That is how I practice. So I believe that you will also follow this kind of a practicing process and learn faster. Let us continue. So now you know how to push the documents, push your data into the Chroma DB. You have got the DB, Chroma DB ready, and you can check it. So you can use it as a retriever, and you can check it whether you can get the data out. So you see that each document is having lesser size. So you see this is the actual data that is available. Okay, and this is 350 characters. Okay, it's less than 350 characters, so it can be lesser or higher. So we can actually check it out. What is stopping us? So we are anyway using Python, right? So let us see whether we can do a length check on this, and let us see what is the output. So we see it is 346 characters long. So whatever split size, chunk size that you are providing, 350, is almost met. So this is how you check every aspect of the programming step can be checked in Jupyter Notebook. That is the main purpose of Jupyter Notebook, for that matter. So we know how it is being done. Now think about it. If it is not 350, if it is going to be 1000, and if 4 different documents are going to be retrieved and sent to the large language model, obviously it will error out, correct? But it is not intuitive. When the error is thrown by the large language model, people, who are new to large language models, who are new to Langchain, don't really understand what is going on. So this is the reason why the error is occurring. So change your chunk size and start working with that. So this is how you create the zip file in Linux. So this is the step I have taken for converting this database into zip file. You can actually use that. Next is the important step. From this place, we are starting to work with the self-query retriever. So the regular retriever, you see, this is a regular retriever. I just call as retriever on the vector DB instance, and it becomes a retriever. It's as simple as that. When it comes to self-query retriever, you have to give some additional information. The additional information is about the metadata. So the metadata that is contained here is source as well as the page number. So you see the metadata here. Once I'm asking for the Langchain concepts, I'm getting the data from concepts.pdf. This is the main point. It is coming from concepts.pdf. It is coming from welcome to Langchain.pdf. All these things has to be properly informed to the query creating LLM. So you remember that internally the self-query retriever will create a query generating LLM, right? To that LLM, we have to provide that where is a source, what is this source actually? It's the file name and location of the source file, and the page is the page number on which the document is found. So this document that we are talking about, so this is found in this particular page 3 inside the quick start guide. This is what we are informing to the self-query retriever. So once we do that, and we give the description also, so we have to create all these variables and then create the self-query retriever. So we provide the document content description, the vector database, the LLM is Vertex AI here. I have kept the temperature of 0, and metadata field info that we created here, the metadata field info, and the verbose equal to true. You can actually use another one option also. It is called as enable limit equal to true. So I will explain what is that in a couple of minutes. Once that is done, now comes the interesting part. Once you give this self-query retriever and then you start getting the relevant documents, you will see that it creates 3 variables like this. This is not something that you create. It is created by the large language model. And this kind of query creation, this kind of variable creation is done using the Lark. You remember I introduced Lark. Langchain has informed that we have to use the Lark library, right? That is done using this. Okay. And then you see the relevant document that has been written. So both of these together, they work. So the large language model creates these query, filter, and agent, and based on these agents query, the series of documents has been returned. And same way, if you want to enable limit, then what will happen is you can tell how many, you can give the numbers. Like for an example, if I say explain 3 concepts of chains, then the limit actually becomes 3. And the query explain 3 concepts of chains, returns this kinds of variable, these kinds of documents. And you can see that using these documents, this is the important point. This is actually retriever. The retriever has to be further converted to the QA chain. So this is, remember, this self-query retriever is one of the parts that is going to be used in the final chain. The final chain is actually the the final chain is actually the RetrievalQA chain with sources. So this is what we are going to use, and for that we will be using the retriever that we created. So once you use that and give a question to the chain, so here I am creating get relevant documents, but here what I am doing is I am using the retriever, getting these documents. Where is it? I am getting these I'm getting these documents, and then I am taking it again to the LLM. Okay, and I am going to use the chain type stuff to get the actual answer. So this is a kind of a double time activity, double time call to the large language model. During the retrieval process itself, we are going to call the large language model, and then we are going to call the large language model during the question answering also. So there are two steps. So again, go back. The difference here is in the regular retriever, in this simple retriever, you are not going to see any kind of large language model. First of all, it doesn't contain any large language model, and it doesn't contain any way to self query. So this is the difference. But the self query retriever will have the additional step where it zeroes down on the query, the filter that needs to be used, and the limit. All these things can be enabled. So I hope that you got a brief understanding of what the self query and the regular retriever is all about, how both are different, and how you can use it. So here's the question. So give me two types of agents. So once I asked the question to give me two types of agents, I clearly get just two types of agents. And if you go and check the agents PDF, you will see that at the initial introduction itself, these two agents are explained. Now, if I ask, give me two examples of the agents, you will not find a proper answer. So you see that I'm getting sequential agent and random agent. I think this is still an hallucination. I did not actually find these agents in my documentation. This could be hallucination, or it could be in the documentation also. So do check it out. And then now I'm asking further questions like how to combine the large language models. These are the questions which is precisely answered. And here I'm asking, give me two examples of combining LLMs. You can check that out in the concepts PDF. And like this, you can, ask, so especially this one, explain consistency in Langchain. You see, there is a method called as self-consistency. You know what happened when I started working on this particular question? I had initially used 100 as my chunking number. So the number that I'm talking about, this chunk size was 100. And when I asked the same question, self-consistency, the answer from the chain, this chain was, I don't know. The large language model, even the self-query retriever, was unable to answer that question. Then I realized, okay, because of the split, the document sizes are small, it is unable to make any kind of proper judgment of how to answer. So once I increased it to 350, I started getting the answer. So such kind of strategies, such kind of challenges will occur once you yourself start practicing. So I believe that you understood the background of how the self-query retriever, improves the retrieval process, how it bypasses or at least improves upon the challenges that the vector search has, the approximate search has, by adding additional query generating large language model, and then how to work with the number of retrieved documents. All these things we have covered in this particular code, and the code has been shared. I believe that you will understand more about self-query retriever from now on, and also the regular retriever, because we have a comparison right now. So you have a better way to learn. And do subscribe to my channel for further updates on not just Langchain. I work on various open source libraries also in Python. So do take a look at my other videos, and do subscribe for further updates on those videos. Share these videos with your friends and colleagues who are trying to come up to speed in this particular artificial intelligence domain. With that said, I would like to come to a close of this discussion with 4 words. That is practice, 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 practice. See you guys. Have a great time.